Okay, building prototypes versus building final systems. You're not going to get it right the first time. We never do in software. We don't get it right the first time in just about anything. Um, it's why we build test models and we try to do as much work in any field to kind of the prove the concept before going out and doing it for real. In software, proving the concept before doing it for real is prototyping. It helps us spot errors in our thinking. It helps us spot errors in the workflow. And the nice thing is when you're building a prototype, you're not prototyping the whole system. Ideally, we can break these things out into individual units and test them individually or in small clusters of related classes that need to communicate. So if you have a class that hasn't been fully implemented, as I mentioned earlier, have a fixed result that gets returned just so you know that the class is returning some information. What this also does is instead of having the result returned result be random, it gives you a fixed benchmark. You know what's coming back, and it makes it easier to trace logic errors that way. If you do need random numbers, instead of using a randomly generated seed, make sure that when you're in testing mode, you use the same seed so you get the same set of numbers in sequence each time you run. And that way, again, it facilitates testing. Now, the notion of a prototype is fairly well entrenched in software development now, but that's not the way software engineering began. In the late 60s, early 70s, when you would buy a mainframe computer, and then you would buy consulting services from the company that sold you that mainframe computer, and then you would buy a software system from those consulting services. And I'm thinking in this case specifically of IBM, because they were the 800-pound gorilla in computing at that time. I mean, there were competitors. There was Digital Equipment Corporation. There was Wang, Osborne, a couple of other mainframe vendors. But International Business Machines, IBM, was the sort of the gold standard. And they defined for themselves and sort of for the industry what software engineering was. They were like, well, building software needs a process. It should be something like civil engineering, where we need to build a bridge or an aqueduct, viaduct, roadways, whatever, which is we do a lot of analysis up front, then we design the solution, then we build the solution, then we test the solution, and then we test the solution in the organization's environments, and then we deliver the system. We enter into maintenance phase. This is known as the waterfall model, and the idea is that you start at the top, and just as water flows down a waterfall and does not go back up, when you leave one process, you have completed that, your client signs off, and now you are moving into the next phase. And it doesn't matter if you discover something at a later phase, it's not part of the implementation, and so you either press forward without it or you have to go back and renegotiate the contract. This notion of a contractual obligation form of software development really was from the mid-70s to the late 80s, maybe early 90s, was the dominant format for software engineering. It was the model that I was taught as an undergraduate, that this is the way you do things, and that you don't write any code until you figure out absolutely everything in terms of defining your requirements. In the 1990s, a group of software engineers got together and wrote something called the Agile Manifesto. And the Agile Manifesto basically says we value working software over requirements analysis. We value collaboration with partners over contracts. If you search for Agile Manifesto, you'll see the basic tenets of it. The idea is, instead of following a waterfall model, well, that was not exactly what I thought I was going to see. They were interested in more of a spiral model. And that model is about iteration, where you come up with some initial planning, and then you do your analysis, you do some, you figure out what the requirements are, do your analysis and design, you build a minimal implementation, and then you test that implementation, you evaluate what it does do and doesn't do. And then from that, you do some more planning on the basis of feedback, and you do the analysis based on that feedback, and you design and refine those features and implement them and test. And this iterative model, which grows the software over time and has checkpoints built in, so that eventually you get to a point where the software is built to a point where it's deployed as a tool and ready for use, has really been in vogue since the .com era. For a long time, Gmail, which many of you use, was actually listed as beta software. And at some point after it had been in use for 5, 6, 7 years, they just took the beta tag off, and it's like, okay, it's now deployed. But everyone had been using it for major work for many years prior to that. Let's look at that spiral, which I had to delete. It's not that you don't have a plan, but the idea is that you're continually evaluating. And at any point, you can determine that, hey, this software isn't meeting the needs, and then you can cut it off and kill the project without it being something that you've invested, tens or hundreds of thousands of dollars in, or millions of dollars in, before you've even written any lines of code. So you're kind of working through those 4 steps of iteration, determining your objectives, building out prototypes as you're also identifying and resolving the risks. You're developing and testing the software, and then you're going into a plan for the next iteration. And then with what needs to be done, what are you building out? So you're in this continual spiral through these 4 phases. And you might not have a complete working prototype until several trips through the spiral. You'll have prototypes of subsystems, and eventually you'll get out here to a prototype that actually has all of the necessary pieces. And you go through that, and once you have all of those operational prototypes, then you can refine them, test them, lock them down. Hopefully you've been documenting all along, but you can release that version of the software, and then you go into maintenance on that version as you begin the next development spiral for new features or new software systems. So even though it looks haphazard, it's actually kind of waterfall-y. If we look at an object-oriented analysis and design graph, it's just that what part of the waterfall gets done as the spiral progresses gets smaller. So what are the business needs? Well, that's very high in the early part, in the innermost part of that spiral, and you're developing your requirements. You're also doing a little bit of analysis, but you haven't really deployed it yet. Over time, you've hopefully completed the business modeling. You know what the business needs are after several trips through the spiral, but you're still figuring out the requirements, and you're still figuring out the software. You've started implementing pieces of it, and you're testing pieces, and then your tests, you have lesser needs for tests as it becomes solid, and then new features come in, and you ramp up the testing and the integration testing. Okay, so as we move from left to right, that's, start of the project towards completion of the project, you shouldn't be needing to do much business modeling towards the end of the project, because that should have been front-loaded. But there might be things that you've missed, so there's still a little bit of height to this bar. So, your analysis and design takes place in the early portions of the spiral, and there'll be less need for analysis and more need for just implementing the analysis as you move farther to the right. As you're moving farther to the right, also, there's probably less need for new implementation and more need for deployment and support. So it's a waterfall with loop back. So you just don't have to worry about everything being quite so willy-nilly, like we're just going to keep spiraling and never have a plan. That's not the point of iterative development. The point of iterative development is to have these bars shrinking over time, but to not think that you do everything and then that step is done. It allows for growth, it allows for increased understanding, it allows for a more nimble approach to the solution that you're trying to develop. You'll learn more about it in the other courses, but this is the mentality you should take through this chapter and as we go through the case study next week as well. Okay, let's shift gears. When we come back, let's talk about design patterns.